Hey guys, how's it going? Today we're going to talk about something really simple to wrap up stats, which is the empirical rule with normal distributions. And our goal is to be able to use the normal distribution characteristics and empirical rule to describe a data set. Now, I apologize if I'm a little low energy. I'm feeling under the weather and I am so paranoid. So if I'm slow to respond, I know I've had a couple emails and things like that, and I'm slow to grade. I really apologize, but I have just been feeling awful. So got to put myself and my health first. So let's get into this really quick, and then you guys will be able to practice. So some general housekeeping is you guys are going to have a quiz on Wednesday or Thursday. Don't worry, you guys are going to be great. It's like an open-ended free response of all of the skills that you have practiced, and you're going to have until Sunday to complete it. Don't try to cheat. I have multiple versions that I'm going to be giving out. So you have until Sunday, relax. But don't call your friends up and have this at work. You're going to need to upload a photo of your work for this quiz, and you're not going to be directly editing the document like we have been with our HyperDocs. So with that being said, I'm going to post a how-to video of how to upload a picture of your work in Google Classroom from a student's perspective. And the topics include, but are not limited to, dot plots, the mean, median, range, IQR, drawing a box plot or box and whisker plot, standard deviation, and using the empirical rule that we're learning today. So just a quick little recap of what we've talked about in the previous section is we talked a little, excuse me, talked a little bit about skewness, right? Is something normally distributed? Is it skewed to the left or right? Something that looks like this, right? If it's left skewed, the tail's on the left. If it's right skewed, the tail's on the right, like the kangaroo. And a normal distribution looks like this beautiful bell curve with the mean is equal to the median is equal to the mode. We also talked about normal distribution characteristics. So normal distribution looks like this. This center part is the mean or the median and the mode, and these are standard deviations from the mean. Now, oftentimes this is just given to you. Like the standard deviation, remember, that's just a whole number that we were able to calculate. A whole number, maybe it's 3. So if the mean was 50, one standard deviation from the mean would be 53. And then 2 standard deviations of the mean would be 53 plus 3 more, so it'd be 56, and so on and so forth. This is the positive direction on the right, and this is the negative direction. This one talked about how to draw a normal curve. If you're given a bunch of information about some data, remember we started off by plotting our mean, and then we figured out what our standard deviation was, and just added however many that is to the right or left, and plotted our normal bell curve. And we also focused a little bit on drawing conclusions from normally distributed data. So that was like when we had this and we were adding up the percentages of the bar graphs underneath the normal distribution curve. So that honestly, that's basically what analyzing normally distributed data is you're taking the area underneath the curve and it's represented by a percentage and just saying this is how much you can expect for a given set of situations. So let's get into it. Recapping the normal distribution, right? Normal distributions are symmetrical about the center, about the mean. So that means this is exactly the same as it is on the left. Notice that this is 34 and this is 34, right? And this is one positive standard deviation, one negative one, right? The mean is equal to the median is equal to the mode, and that is in the center right here. The mean will always be the highest peak. It will always be equal to the median and always be equal to the mode as long as you're working with a normal distribution. It is unimodal. There's not more than one peak. There's one ultimate high peak, and that is it, giving us our beautiful bell shape. It's asymptotic, meaning that these parts of the graph, the tails never actually touch the x-axis. And it represents many biological phenomena like weight, height, etc. of things in nature. This is why we talk about normal distributions so much, is they just really model a lot of things in the real world. And lastly, it follows the empirical rule, and I'm about to show you what that is right now. And it's really not too bad, I promise. But The empirical rule is referred to as the 68, 95, 99 rule. Sometimes they get a little bit more specific, but basically from our normal curve, we have 50% of data on the left and 50% of the data on the right. So 50 plus 50 is 100% of your data. This curve represents 100% of your data. And within one standard deviation, here's the mean. Let me get a pen. Right? If this is, woo, oh my goodness. If that was the mean and it's a straight curve, in this direction, that's one standard deviation, and this is one standard deviation. So within one standard deviation of the mean, it has 68% of the data. Within two standard deviations of the mean, so here's one, here's a second one, all the way out here, we have 95% of the data. And then lastly, if we extend it all the way out to three standard deviations of the mean, oops, I don't know how I did that, all the way out to like this little tick mark right here, oof, that has 99.7% of the data. So it's pretty cool. If you remember 68, 95, 99, you basically know the empirical rule. So again, just what it says is that 68% of the data falls within one standard deviation of the mean. This is 68% here. Two standard deviations, notice this is -1, this is +1. From 0 to +2, 0 to -2, that's going to cover 95%. 99.7% of the data falls within three standard deviations of the mean. And above all, in order to use this, you absolutely must have a normal curve, or you must have a normal distribution. You cannot make assumptions on things that are skewed like you can with this. So that's what makes the empirical rule so cool. So I'm going to show you a video that breaks it down really nicely and kind of gives you the type of questions that you'll be seeing from this. So let's play this YouTube video. What I want to point out here is he is shading under the area, and that's how we typically look at normal distributions and what we have going on here. So notice that he took 68 and divided by 2 and got each chunk because it's symmetrical. Now, since it's 100%, 68% minus 100 leaves 16 on either side. Notice that this is from the middle, right? So he's splitting up 95 in half like he did before, but now he's going to categorize how much this part is because it's not all 47.5. From the mean all the way to the second standard deviation is 47.5, but this chunk is a separate percentage. On each side. No. No. So what I want you guys to do actually, before we move on, is go back and pause that, and you need to write, excuse me, write down that information. It's going to be super helpful when you're working with the empirical rule. And then let's figure these types of problems out, which are very typical. He got this from the information over here. The mean is 60 in the video, and it gave you the standard deviation of 5. They will always give you that value. I want you guys to notice how he got those numbers and make note of that. I think that will make it a little bit easier when working with standard deviations and the mean. So look at the information that's given and look at the information that we just plotted on the x-axis and make a note of how we got there, how we got those values. That one's kind of tricky because you're talking about area. So you could also just add up the 13.5 and then the other tail and the last tail. You could do that as well. But oftentimes it's easier just to take a value that we know and subtract off one thing instead of adding up multiple. But you can certainly do that either way. Now, whenever you're saying the area below a curve, we're always meaning in the left direction. If we're saying a greater than, it's to the right side of the curve. So that is something you definitely want to make note of. When it says greater than, you mean you're shading to the right. When it says less than, it says you're shading to the left. When you're between, you shade between those two values on your normal curve. So I think he did a really easy application of how to do this. You could certainly add up all of those values too, but he makes it really nice to see exactly what they're going through. So how do we use the empirical rule? So one last video for you guys. And my pro tip for you guys is to follow along on a piece of paper with this video and with all of the videos really. Whenever I post a lesson, the more you practice, the more comfortable you'll get. Um, you cannot observe math, you actually have to practice it and do it. Super close. Now, the last part of that, when he said the upper side, he meant to the right. So when he was, calculating those values, he was finding the upper half on the right and solved it algebraically, found that it's 3 standard deviations. Alrighty. You guys will have a little bit of homework, and you guys will have a little bit of homework, not too much, and I want you guys to just study up, and that is it for normal distributions and the empirical rule. Alrighty. Have a great day, guys. Bye.